Ji, Assalamu alaikum. Once again, or today we will be discussing some concepts of forces, right? So let's have a quick review of the previous concept that we studied in the last classes. Okay, we started off with the basic concept of force, right? And force is actually the push or pull, right? Okay. And force can be measured with the force meter, Newton meter, or spring balance. ठीक है? And further, we also did one example where the mass was given, and we have to convert that mass into weight. Weight is actually the downward force, and mass is the amount of matter present in a body relative to the observer. This is the definition we studied in the last class. The quantity of matter present in a body relative to the observer. And we also had a discussion around this concept that what is the meaning of relative to the observer, since whenever we are taking measurement of mass, so actually it can vary depending on the observer's frame of reference. So since mass is a fundamental property of an object, so it's a measure of how much force is needed, how much force is required to speed up or to, to move the object to get from one point to another point, or to accelerate an object in the one frame. Okay. Uh, then we discussed about the fields, and it is also related to the force. So we discussed about the magnetic field, because normally we understand that how magnet looks like, and the region and the space around the magnet, any magnet, it is called a magnetic field, where another magnet can experience a force of attraction or repulsion, right? After that, we linked the magnetic force with the gravitational force. So we linked uh, with the gravitational field. So it is instead of having the magnet, we are having a planet or an object, but the object should be a massive one that has a huge mass. Uh, and after that, what we can say that around that mass or around that object, the gravitational field can be experienced by another object, right? Right. Acha, when we talk about that a massive object, right? So it also depends on the distance, how far you are, considering the object is. So definitely, if someone asks, what is the noticeable mass, that is, or what is the minimum mass of any object that is required to have the gravitational field. So definitely, I would say that a field which can be measured by any instrument is in existence, the most sensitive instrument possible, right? So we have to have the most sensitive instrument which is possible, and that can detect the gravitational field. And actually, gravitational field is because of the gravitons, right? So there would be an instrument that could detect one graviton. As I have just told you, that gravitational field is because of the gravitons, right? Just like protons, electrons, mesons. So there could be many, and there could be the series of the particles. So one particle that that gives off the gravitational field, or that makes the gravitational field around its own, domain, around its own existence. So that would be an instrument. There should be the instrument which can detect one graviton or the number of gravitons, right? So, well, I don't know for sure, but it would not surprise anyone if we have that, for at least for some situations, right? Uh, Let me add one thing more here. Uh, there must be the frequencies that are involved in it, and if there are more, if the higher frequency particles are there involved in it, so there would be high energy. So it might be possible to detect individual gravitons more energetic than ordinary ones. So we can't say that noticeable mass or any such term, or minimum noticeable gravitational field, but it depends on the distance, and it depends on the mass as well, and it depends on the number of gravitons, right? Well, it is not a part of the syllabus, so you do not have to focus more on this. Uh, well, you just need to understand whenever there is a mass, there must be the gravitational field around it. Okay. And if there's a huge mass, if there's a massive object, then there will be the large gravitational field around it, right? So gravitational field is the region around a massive object where gravity can be detected or experienced by any other massive object or any object, right? Um, Over here, we discussed that how the fields cancel out each other, and the point where the gravitational field cancel out each other, that point is called null point, where the strength of gravity becomes zero, and definitely the weight would also become zero, and there would be no resultant force. Over here, I think I introduced the resultant force. That resultant force is the net force or sum of all forces. So this concept is going to be discussed again when we are talking about the the free body diagram, right? So free body diagram that shows the external forces that act on an object and represented by arrows. All forces should be drawn at correct position. Okay, so we have to keep this in mind that all forces should be drawn at the correct positions, and the size of the arrow there is according to the size of the magnitude of the force, right? How much force is applied on that particular object, so the size of the arrow should be drawn accordingly. So friction force, I considered two things here. Weight of an object is actually at the center of the gravity, pointing downwards, right? So in simple words, you can say weight is a force that acts downward, right? Number one. Number two is friction force is between the block and the ground. For example, if any object is moving, so if it is moving on the ground and if it is making any contact with the ground, that means friction force is there. Okay. So friction force is there between that object and the ground, right? So the direction of the motion, as I have shown here with the one arrow, and it is larger than the friction arrow. So we can understand uh, that the direction or the forward force is greater than the backward force, and backward force here is the friction, right? So now we are going to talk about that how the resultant RF, what does RF mean here? As I have mentioned this in the in the above, pointers, that are resultant force over here. Yes, I have used this word resultant force, right? Resultant force. So this is RF, right? So resultant force is sum of all forces. Okay. So if I say that um, 2 Newton force is acting to the right side on this object, right? And I am just making the object like a block, right? And 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. Let's say this is also 2 Newton, right? Now, I'm going to call this F1 and this is going to be F2, right? So what we can do is F1 is equals to 2 Newton, right? And F2 is going to be minus 2 Newton. Okay, right? So why have I put minus here? Because in order to show the difference between the direction. So this minus shows this negative sign shows the direction. That is up, it is opposite to the another force. Okay, negative sign shows the direction. Shows the direction. Okay, to opposite to um, other force. Okay, right? So if I ask you to add them, so it's going to be the resultant force RF, right? So F1 plus F2. You just simply add them, and what will you get? F1, you by just putting the values, you will get the answer. What's the value of F1? It is 2 Newton, and F2 is minus 2 Newton. So it's going to be plus minus minus, it's going to be 0, right? So what you have found here, resultant force. That means the body, when the resultant force becomes 0, so there are two possibilities. There are two possibilities. Either there are two possibilities. Either object is at rest, right? Or there's another possibility. If the resultant force is 0, that object is moving, object is moving with right? So object is moving with same speed or constant speed. That means the object is not speeding up or slowing down. It is it is not changing its speed. It is not accelerating, right? So or it is not decelerating, right? So 0 Newton is acting. That means that if the object must be at rest or if it is moving, then it must be moving with the same speed or constant speed, right? Acha, there could be another case. If the object is placed, let consider this object is placed on the table, right? And on the table, right? So there are again two forces. So I would say the forces act in pairs. Remember, right? Forces act in pairs. This you have to memorize, and you are going to apply, or you can observe in different cases, right? Okay. Forces always act in pairs, right? For example, how the forces are acting in pairs. Um, the downward force, as we have just studied, the downward force is the weight, right? ठीक है, weight होता है. And the upward force is going to be if the object is not coming down, it is not sinking. That means the downward force and the upward force is going to be same, right? Okay. So I'm going to call that force a normal force, or uh, a contact force, right? Contact, not a constant. It's a contact force. Okay, contact force. Contact force, right? So we show with the capital C. Okay. So capital C is moving, is upward, and W, that is the weight of the body, is acting downward, right? So it's a weight. W means the weight, right? It is also the force. Now, when both are equal in size, right? The arrows, you can see the both arrows are equal in size, right? So if they both are equal in size, I would say that this has become uh, shorter. So I need to increase its length. 1, 2, 3, 4, and 5. Now I think they both have become equal. So I can write C equal to W. That means it is balanced. Balance means there's no resultant force. An object must be at rest, right? No, object is not sinking. I would say here object is not sinking. Sinking, it is not coming down. Okay, is not sinking, right? For example, if there's a car, right? And let me draw that car that you can, easily understand. I don't know how have I made it, but you just need to understand. You can imagine yourself. Well, the weight of the car, and it is on the muddy surface, right? It's a muddy surface, right? Okay. Now, if the weight is increased, for example, if only one person is sitting, so the car is not sinking. That means the the total weight and the total contact force are balanced, right? Okay. But when another person gets entered the car, so weight becomes greater than the contact force, right? What is going to happen? What is going to happen? The car the car starts to sink, right? Why? Because the weight has become greater than the contact force. Okay, right? So what is going to happen? We are going to draw the weight arrow larger and the contact force arrow smaller. Okay, and what is going to happen here? A car is going to sink. Is going to sink, right? As weight is larger than the contact force. Contact force, right? Okay. Now, if I say the total weight, total weight of the total weight of the car is 8,000 Newton, right? Including you know, the number of passengers, the number of people are sitting there. Okay. How much force? How much force is needed or required to lift the car or to balance the car, right? To balance the car. Now, how much force is needed to balance the car, right? So obviously, if it is 8,000 Newton, right? So the weight of the car is 8,000, right? But definitely, of course, the contact force is going to be 8,000 Newton. Okay, right? Or greater than 8,000, right? Okay, not less than 8,000, not less than 8,000. I hope this is clear. Um, okay. So contact force and weight is, I hope it is clear now. Uh, let's talk about, uh, okay. So if 8,000 Newton is the total force, right? So what is the force, that is so much easy. It's not a difficult one. What is the force acting on each tire? Yes, obviously 8,000 divided by 4 because there are 4 tires, so it's going to be 2,000 Newton, right? On each tire, 2,000 Newton is exerted, right? And what is the direction of that force? It is downward, right? So, all right, sorry. Uh, so 2,000 Newton on each tire, right? On each tire, right? And the direction is downward. Direction is downward, right? After that, uh, we have the topic of formation of solar system, right? Solar system, right? Right. So when we talk about the formation of solar system, so the gravity plays a very vital role for the formation of solar system. That is, I would say that that is the force, or that could be only the force responsible for making the solar system, right? After that, we all believe that billion years ago, the solar system and especially a nebula, right, was formed. So we are going to see that how nebula was formed, right, and what nebula is, right? So, uh, as we know that uh, the particles, okay, when particles combine together, then mass is increased, right? Mass is increased. Okay. So I would say that there were some few particles, right? There were some few particles, right? And they were having some of the forces around them, right? Okay. Okay. And then they started to collapse each other, right? Collapse each other. And they further they interacted and combined, right? Further they they interacted and combined to form a rock, or um, I would I would say cloud, okay, of dust, right? Acha, in that cloud of dust or rocks, the there were not only particles involved, there were some gases as well, right? There were some gases, right? Um, we would say that mainly hydrogen and other gases, hydrogen and helium, right? Most of the gases were hydrogen and helium, right? So uh, but it includes atoms, right? Atoms and dust grains of heavier materials, right? For the generations of the stars. Okay. All right. So there were some gases, mm, like uh, helium and hydrogen, right? So what we can say, what was the starting point? It was a there were gases and dust, right? Okay. And most of them were hydrogen and helium. Okay. And then the nebula it was being formed. Okay. And what was nebula? Nebula is the cloud of dust and gas particles, right? So what happened was, once the nebula was formed, right? So the next was that more particles were attached to nebula and form a big uh, rock or a kind of object, right? So more number of beta, more number of particles were attached to nebula to form a big object, right? Big object, right? Obviously, we have learned this concept uh, as the object is increased in size and particles are added, then the mass would also be increased, right? To form a big object, that means there was a increase, there was an increase in mass, ठीक है? Mass में increase हो गया, ठीक है? उसके बाद क्या हुआ after that the strength of gravitational field increases. Okay, ठीक है? Uh, right. So the next chunks of rock, dust, and ice and other particles, that were called as planetesimals began to form in the outer nebula, right? Okay. Acha, what could be the alternative term for planetesimals? Planetesimals के लिए alternative term आप ये use कर सकते हो, heavy materials कह सकते हो, asteroidal कह सकते हो, ठीक है? Planetoidal, you can use planetoidal, celestial body, heavenly bodies, right? Okay. So you can see this picture here. I have attached it here, right? तो इसको मैं थोड़ा सा enlarge कर देता हूँ. Oops, sorry. ठीक है. Okay. So uh, planetesimals collided, began to form planets. So what happened was the big rocks and big objects were formed, and then they started big objects started to collide, right? And begin to form and begin to form other objects. क्यों? क्योंकि जब आपस में कोलाइड करेंगे, yes, there could be the destruction, and yes, new objects can also be formed due to gravitational field of attraction. Okay, gravitational field. Okay, and begin to form uh, other objects. ठीक है, क्योंकि वो जोड़ेंगे टूटेंगे, जोड़ेंगे टूटेंगे, इस तरह हो रहा है. ठीक है. So what we can say, the cloud starts collapsing. Yes, we can also say that cloud starts collapsing since they have their own gravity, right? Because they have the mass, right? Uh, उसके बाद हमारे पास क्या होता है कि when the enough size is achieved, when enough size was achieved, when enough size was achieved, so at particular temperature, at specific range of temperatures, at specific range of temperature, the object, the body, the object remains a planet, because उनका आपस में टकराने के बाद कुछ ना कुछ टेम्परेचर भी तो इंक्रीज हो रहा है ना, right? Remains a planet. Otherwise, if the temperature becomes so high, right? So what we can conclude here, that stars are hotter than planets, stars are massive than planets, right? And yes, stars have greater gravitational field strength than the planets. Okay, so till here we are going to end up our class. Hope you have learned new concepts. Inshallah, we will be uh, meeting in the next class with a new concept, inshallah. चलें जी, स्टे ब्लैक्स, अस्सलाम वालेकुम, अल्लाह हाफ़िज़।